This is a portion of a mechanism removed from a tank gauging system. It's a float and tape style tank gauge, and it has a crank over here that gets turned by the tape mechanism. Then over here it has a worm gear assembly that turns this wheel very slowly compared to the rotational speed of this shaft I'm turning with my finger. As you can tell, it's a significant gear reduction ratio. If I take a look at the rate that it's turning, I'll line up some index mark like that little set screw right here, and I'll count how many turns of this shaft I have to turn for that to go around once. So here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So it's about a 13 to 1 turn ratio there on my gears. So a 13 to 1 reduction in speed and a 13 to 1 increase in torque. The real reason for this video is to show you what a worm gear actually looks like and how we achieve this. You can see that. Take my flashlight here and shine into the worm assembly. There's actually a round gear called the worm gear, and there's something that looks kind of like a screw called the worm screw. The worm screw is right here, pointing with my screwdriver, and it looks like the threads on a bolt or the threads on a screw. They are turned by this shaft right here, and as that shaft is turned, just like the threads on a screw, the threads appear to be moving in one direction, and they engage with the teeth on the worm gear further down below, causing it to turn at a relatively slow speed. So you get a large reduction in speed and a large increase in torque, and that is a worm gear assembly. And we see worm gear assemblies all the time for mechanical speed reductions from motors, and especially true for motor actuated valves. If you have, let's say, a rotary valve that's turned slowly by a shaft, like a ball valve or a butterfly valve, you could have a relatively high-speed motor turning a shaft over here, resulting in a fairly slow rotational speed of the shaft that turns the valve. It's also used on gate valves and other rising stem valves, where the stem of the valve has its own set of threads. A slow-turning nut causes that stem to rise up or fall down to open and close the valve. And once again, a relatively fast-turning electric motor would be able to make a rising stem valve open or shut. So worm gear mechanisms, very handy, often used in the electric valve actuators, and this happens to be a demonstration of one that came out of a tank gauging mechanism.